Shaping the Data Universe, Large-Scale HDFS Deployments at Yahoo and Facebook. This presentation will explore how two internet giants tackled the monumental challenge of storing and processing unprecedented volumes of data, paving the way for the modern big data era. By the late 2000s, companies like Yahoo and Facebook were generating data on a scale never seen before. The problem was stark. Traditional storage solutions were expensive, fragile, and incredibly difficult to scale vertically. The solution emerged in the form of Hadoop's distributed file system, HDFS. It was scalable, fault-tolerant, and radically cost-effective. Yahoo and Facebook were the pioneers who didn't just adopt this technology, they pushed it to its absolute limits, stress testing it in production at a massive scale and contributing back to its evolution. Yahoo stands as the original pioneer and primary contributor to HDFS in its early years. At its peak between 2010 and 2012, Yahoo operated one of the largest Hadoop clusters in the world. This consisted of approximately 4,000 nodes, storing over 100 petabytes of data, and managing billions of files and blocks. Their architecture was built around centralized, massive clusters that served the entire company. These clusters supported critical workloads like search indexing, analytics, user personalization, and fraud detection. Crucially, Yahoo's engineering contributions were foundational, including the integration of Kerberos for security, the development of HDFS RID for efficiency, and a suite of operational tools for managing such a vast system. From Yahoo's journey, we gleaned several key insights. First, creating a centralized data fabric empowered the entire company with powerful, unified analytics. However, this centralized model introduced the challenge of noisy neighbors where a single large job could impact the performance of many others. To make HDFS enterprise-ready, Yahoo led the charge on integrating robust Kerberos security. Perhaps their most critical contribution was in operational hardening, developing the necessary practices for deployment, monitoring, and recovery at a scale that was unheard of at the time. They proved HDFS could run reliably in production. Facebook's explosive user growth necessitated innovations that pushed scale and efficiency even further. From 2012 onward, their infrastructure grew to encompass tens of thousands of nodes, eventually reaching an exabyte scale of data. Their data ingest rates were staggering, petabytes per day and tens of terabytes per hour. To manage this, Facebook moved away from a single, monolithic cluster. They pioneered an architecture using federated namespaces and multi-data center clusters. Their workload profile also evolved from pure batch processing to a complex mix of batch, interactive, and near real-time queries. Facebook's engineering contributions were pivotal in overcoming HDFS's next set of limitations. To solve the single point of failure of the NameNode, they developed HDFS Federation, which splits the namespace across multiple independent name nodes. They also created avatar nodes, providing a hot standby failover capability that became the basis for HDFS's built-in high availability, or HA feature. Driven by immense cost pressure, Facebook relentlessly pursued efficiency through hardware and storage optimizations. Their most significant contribution was the implementation of erasure coding, specifically Reed-Solomon coding, which dramatically reduced the storage overhead from the standard 3-replica model to approximately 1.5 times, saving massive amounts of storage capacity. In summary, Yahoo and Facebook followed different but equally influential paths. Yahoo perfected the model of large, centralized clusters, achieving petabyte-scale reliability. Facebook, facing even greater growth, embraced federated clusters to enable exabyte-scale expansion. The key innovation areas differed. Yahoo focused on security and operational robustness, while Facebook drove advancements in federation and high availability. Their workloads also reflected their needs. Yahoo was initially batch-heavy, while Facebook demanded a mixed workload environment from the start. Despite their different paths, both companies faced common monumental challenges. The NameNode single point of failure was a critical bottleneck ultimately solved by federation and HA. Metadata scaling became an issue, as billions of files require enormous amounts of RM for the NameNode. Operations like rebalancing data or bootstrapping new nodes became incredibly complex endeavors across thousands of machines. Hardware failure shifted from being an incident to a daily norm, a standard operating condition at 10,000 plus nodes. Finally, ensuring quality of service and multi-tenancy was addressed by YRN, which allowed for fair resource sharing among diverse users and applications. In conclusion, the blueprints created by Yahoo and Facebook for large-scale HDFS deployments became the model for the entire industry's modern data lakes. Their work directly enabled the large-scale AI and machine learning data processing we see today. While the industry has since shifted towards cloud-managed services and object stores like S3, the legacy of HDFS is undeniable. It served as the foundational bedrock upon which the entire modern big data ecosystem is built. Thank you.